Dilations, as we talked about before, is just a reduction or an enlargement of a figure. We have what's called the scale factor, and that just tells us how much the figure was made bigger or how much the figure was made smaller. So the scale factor, we'll just call it K. Doesn't matter what you call it. It's just a reduction if it's anywhere less than 1. So you're going to probably get a fraction, 1/2, 1/3, 1/4, 1/18, whatever it is. If it's less than 1, or if it's less than 1 but it's still got to be greater than 0, then it means that it's been reduced. So it's been cut in half, it's been cut in 1/3, it's been cut in 1/4, it's been cut in 1/18. If the scale factor is an enlargement, then it's a number greater than 1. So 2, 3, 4, 5. So that means the image has gotten 2 times bigger, 3 times bigger, 4 times bigger, etc. Dilations are not isometries. Remember, an isometry is a congruence transformation. It means that after we've transformed it, that the image is exactly the same size and shape. And clearly, if a dilation is a reduction or an enlargement, then it won't be the same shape or same size. So they are non-congruent transformations. So we can figure out what the scale factor is when we have a dilation by taking the dilated image over the pre-image. Their size gives us the scale factor. So here, the original diamond has a size of 1, and the dilated image, P prime, has a size 2 times bigger. So we take the pre-image size, which is P prime, so 2, over the image's size, which is P over 1. So the scale factor is 2, so clearly this was an enlargement. Okay, so I'd like for you to pause the video and tell me what the scale factor is for letter B, and then tell me if it was a reduction or an enlargement. So we look at our original, which is P, and clearly, just by looking at it, it's a reduction, because P gets smaller and turns into P prime. To figure out what our scale factor is, we take P prime, 2, over the size of P, 3, and we get our fraction, our scale factor of 2/3. So P prime is 2/3 the size of P. So when we look at dilations on a coordinate plane, we have to look for the original image and then compare it to its image after the dilation. So clearly A, B, C, D is our original, got bigger. So it's definitely an enlargement. And we can just see that by looking at the picture. Now, to see what the scale factor is, what we're going to do is we're going to just take one of the coordinates and identify the position of the coordinate. So I'm just going to take B. B has the coordinate of 1, 2, 0. Then I'm going to look at the coordinate of B prime. 1, 2, 3, 4, 0. So to see what the scale factor is, remember we would take B prime over B, and that gives us our scale factor. And in this case, we can't do 0 over 0. That's not going to tell us anything, because 0 multiplied by any number is still 0. So we look at the number that did change, the 4 and the 2. So we take B prime, which is 4, over B, which is 2, and reduce it, which is 2. And that gives us our scale factor. So it has a scale factor of 2, meaning that ABCD got bigger by 2 times bigger. Okay, so in the next example, this is just a little bit of review. We want to identify the transformation that maps figure ABCDE onto figure STUVX. It actually kind of looks like a rotation, but if you trace it on your tracing paper and then try to rotate it, it's not going to fall back on itself. Look, it's going to be off of it. So it's actually ending up being a reflection, and it's on the line y equals x. So that's a reflection. The next question asks, what's the pre-image of V? Well, the pre-image of V is going to correspond with the letter of the same location in A, B, C, D, E. So right here. So V, when it was reflected, was originally D. So you pause the video and tell me what the image of A is. And you should get S. So when A was reflected along the line y equals x, it falls on top of x. I mean, S. Oops. Sorry.